All right. Hey, everybody. How's it going? Doing good? I had never been to GrrCON before. This place is great. This is a way bigger crowd than I had expected, and I'm really, really glad to be here. I really appreciate you guys coming out and go ahead and enjoy your lunches. I'm not going to feel bad. I'm a little bit jealous, but I'll get there after this. As far as this talk, I wanted to walk through a series of attacks that I think are basically just taking advantage of misconfigurations or frankly lack of configurations. They're not particularly fancy things, but they are effective and they work. And I use this to talk with my customers about just basic security hygiene, and this is some of the really simple stuff that seems to open people's eyes really wide. But it's fun to go through, and would happy to show it to you today. When I talk with my customers about security, sometimes what happens is they just have this mindset that they're not really that attractive as a target. You know, they don't think that they're going to have anybody coming in and try and steal their data, so what would I do about it? And I wouldn't be able to stop them anyway because I only have like 2 people in IT or something. I usually try and talk to them and tell them that the attackers might not be coming after you. They might be trying to get you as a way of getting into another target. You might be getting exploited to use that relationship that you have with that customer, and so you have some obligation to do something better than nothing, right? And this, I've actually have an example of somebody just last week that I found out that their email had gotten compromised, and they used that to start a conversation with one of their customers and was able to then steal a bunch of money from them, and that customer relationship ended up getting soured. So we're going through the process of helping them harden their security now. And we also hear people say, like, well, you need to get my passwords, and my passwords are super strong. And well, that's totally not true. We all know that's bullshit. And people say patching. Patching, obviously, we need to do, but that in and of itself is not your security measure. It does prevent you from, certain kinds of exploits and things, but it is not the end-all of security. And then getting into our network, you need to be experienced and sophisticated. Well, I'm not experienced and sophisticated. I'm a blue team guy, I'm a Microsoft guy, but I know how to watch YouTube. So if we can learn some things from these attacks, it's that you don't have to do something very clever, but they are still very effective. So what I'm going to go through are honestly some really lazy, really loud kinds of attacks that should be easy to detect, but not a lot of places are actually doing monitoring and alerting and being able to react quickly enough to these kinds of activities. But they also are very easy to understand because they use tools that you're usually familiar with or have seen before. Of course, there's better tools and suites of tools out there that you can use, but to the uninitiated, it can feel a little abstract, like it's black magic, and you have to be a ninja to do this stuff. So I'm not going to do those things. I'm going to use the kinds of things that your regular IT guy already knows. So to kind of preface the way that this talk is laid out, I kind of broke it into 3 different sections, kind of like you'd seen on some of the kill chain talks. You're going to go through and get into the environment. Once we get into the environment, we're going to look around and figure out what's out there, and then move from the machine that we initially get a foothold on, and then we'll go ahead and start stealing some stuff. We broke it into 3 different machines to kind of embody these different stages. So first we're going to take a workstation and compromise that. From that workstation, we're going to jump over to a server and compromise that. And from the server, we'll jump over to Active Directory, compromise that, and steal all the things. Sound fun? Let's go ahead and do that. I'm Shannon Fritz. I'm a solutions architect at a company called Concurrency. We're a Microsoft partner, and we focus largely on Microsoft products and services. So that's where my experience and time is spent. And we work with customers on just changing the way they do business. And we do a lot of talks and work around security lately because it's such a hot topic. But when we start in here, I want to kind of set the stage that one of your employees lost their laptop. And it could be lost in any means, right? Maybe they left it on a train, maybe they got mugged, maybe somebody went to a bar and they left it when they went to the bathroom and then it disappeared, right? So what could go wrong with the missing laptop? In many cases, it's just someone's going to re-image that machine and give it to a sibling as a Christmas present because holidays are coming up. But what could happen if there was actually a malicious actor who wanted to do something with it? What could that laptop give them? Well, if we jump over to this workstation, let's assume that this is the laptop that I'd stolen. Right out of the gate, we can determine some information just at the login screen. We can see who owns the machine. We can see the company that owns the machine. But if I wanted to log into this, I need a credential, right? I need a username and password. Well, the username is already filled in for me, so thanks for that. But I don't know the guy's password. If you're using Windows Hello, we can use gesture-based sign-in to get into the machine, so we can do things like type a PIN, but I don't know the guy's PIN, so that's not going to help. I could use fingerprint sign-in, but I don't have his finger, so that's not going to work. Windows Hello can also do facial recognition sign-in if you have one of those RealSense cameras. And that's all really useful things for end users to sign in the machines. And usually what I tell customers, if you do use Windows Hello, you should coincide the implementation of Hello with a better password policy. So you can say, now you need to use a longer, more complex password, but you actually don't really have to type it in at the login screen because you can just swipe your finger or use some other gesture to get in. So you can have better credential hygiene, but still give users a simple experience to sign in. But me as the attacker, I don't have any of those things. I can't get into this machine with it. So what I can do instead is simply go ahead and reboot this computer and attach to it the Windows setup CD. Right? Maybe it's the CD, maybe it's a USB drive, but we'll go ahead and boot from that setup disk. And the setup disk is going to run WinPE, which is the pre-installation environment. You just download the ISO, run WinPE. And all that really does is run the machine with enough drivers and things to interact with the hardware. And now what I can do is pretty much anything, right? Because it's running a variant of Windows. I can run any kind of Windows applications on it. But I can also just hit Shift F10 and it brings up a command prompt. And this is WinPE just does this out of box because, you know, as I'm trying to make an imaging CD, I need tools. Well, if I have a tool set, I could plug it in and run those. But let's just say I just want to take a file. So the easiest thing is literally just use Notepad, go to the file, open dialog box, and I can start browsing this computer. Right, so I can use this as like a poor man's file explorer and just kind of browse around a little bit. You can see I've got on here a CD drive, I've got the C drive itself. So let's browse into this, the C drive where we've got the Windows directory, we've got a users directory. There's a couple of users that have logged into this machine already, and this is David's computer. So let's go into David's folder, go into his documents, change the file type to everything. And then we can see, okay, he's got some stuff in here about understanding smart cards. Let's go ahead and copy that because it's probably important. Go to the USB drive, paste it, and then zippity-doo-dah, I just went and stole some files, right? That's not particularly useful as an attacker if I'm going to go and try and browse around and steal a bunch of things. But what it does do is give me the ability to go ahead and take that file without a lot of work. This was some pretty simple stuff. I want to do better than that, though. I want to actually get into this machine. So what we can do instead is close this stuff out here. We'll go to the C drive, if I can type correctly, go to the Windows directory, go to System 32, and there's a file here called sethc.exe. And if I copy sethc.exe, I'm sorry, let's copy cmd.exe over top of sethc and say yes. So now what I've done is I've replaced the sethc file with a copy of the command prompt, right? Does anyone know what sethc is? I'm sure somebody knows what it is, right? Sticky keys, right? And what's sticky keys? Yeah, it's an accessibility option, right? It allows you to be able to invoke the use of the shift key if maybe you only have a couple of digits on your hands or something, right? You can hit shift 5 times, sticky keys runs, and then the next things that you run will be as if you were holding the shift key. Well, because it's an accessibility option, it is available at any time that Windows is running. And since I just rebooted Windows off of the hard drive now and not off of the setup disk, if I use sticky keys 1, 2, 3, 4, 5, it actually runs right at the lock screen. And now what I can do is see that not only am I running it in an elevated, I'm also running as system. So at the lock screen, before having any kind of credential, I now can control this machine in entirety because I'm running in the system context. And this is is pretty powerful, right? Because now I can do anything as this machine. Well, now that I'm in the computer, I still can't really be interactive, right? I can't use the UI, which is like Windows, right? We need to use the GUI. So let's comp ngmt.msc. We'll open up the Computer Management Console, and because I'm running this in the context of the system, I can do whatever I like with it, including going to the users, and I can see that there's actually an account here called local admin. Now, if I want, I could right-click on this and reset the password and log in as that account, and that's all well and good, but there's some better things I can do with that account, and we'll save that for later. So let's leave local admin as it is now, and we'll go ahead and we'll create ourselves a new user. We'll give them a clever username and a clever password as well. And we don't want to change that password, so let's hit and create. And then we'll go to the properties of our new Haxor account, and we'll make this user a member of administrators. And then we'll go ahead and close this out. Tell Windows we want to sign in as another user. We'll log into the local machine as Haxor. And lo and behold, I can now log into the computer. So that's pretty useful, right? Like, that's one that I think you guys can remember without a heck of a lot of training. This is just reboot, replace sticky keys, log in, and create yourself an account. So while it's doing that, let's jump back over here to the slides, and we're going to revisit this question a couple of times, which is what could have stopped that? Yeah, I'm using Hyper-V, right? So I just have console on the machine. So whether it's on Hyper-V or VMware or physical. Yeah, totally. So what would stop me from being able to do that sticky keys hijack? Hard drive encryption, right? Because what I did is I booted that machine out of the context of the operating system that's on the disk, and then I was able to manipulate the file system. So if I can encrypt that file system, then I can't change those files, and then that whole sticky keys hijack thing goes away. So using BitLocker is actually really easy. It's included in all of the Pro and Enterprise editions of Windows. You literally right-click on the C drive and say Enable BitLocker, and it walks you through the wizard to do it. That's all well and good for kind of one-off setups of BitLocker, but if you actually want to manage it with group policy, there are some settings that will allow you to configure what happens when you turn on BitLocker. So you can say, BitLocker's been turned on, I need to store the recovery keys in Active Directory so that as an IT administrator, my user encrypts their stuff and their hard drive, or more specifically, the machine takes a dump, and now you need to get some stuff off the drive. You can use the recovery key to actually read it. If you don't have the recovery key, the data's gone if the machine can't boot in its native or its original way that was set up when BitLocker was turned on. If you want to actually deploy BitLocker post-operating system deployment, right? You have machines out in the field and you want to turn it on. You can't do that with group policy. You have to use an agent, and that's what MBAM is. It's the Microsoft BitLocker Administration and Monitoring. MBAM does allow you to store the keys in an encrypted SQL database instead of in Active Directory, or both if you prefer. But that way you can have an agent out there that will tell you these machines are supposed to be encrypted and turn BitLocker on for you. Another option you have with Windows 10 is Azure AD Join. It's different from Active Directory Domain Join, right? Azure AD Join is a new thing inside of Windows 10 that allows you to register the machine against Azure AD. And Azure AD you would synchronize with Windows AD, so you have the same user identities in both directories, but the machines themselves do not exist in Active Directory. They are a registered device in Azure AD. And an Azure AD Join machine can also be managed with MDM, more typically Intune. So you would manage it like you would your mobile devices. But we can then have devices that are Instant Go capable. As soon as they Azure AD join, they just turn on BitLocker. So there's nothing to configure, nothing to change. You literally Azure AD join a machine and BitLocker turns on, and it stores the key for you in Azure AD. So that's a pretty easy one to do if you're using Windows 10. And as far as monitoring goes, that whole activity that we did on changing that file, if we were using something like Windows Defender ATP, which is actually a different thing from Windows Defender. Windows Defender ATP is kind of a behavioral monitoring solution for Windows 10 Enterprise. And if you onboard those machines to ATP, it will actually be able to identify activities like the sticky keys hijack. It will see process forking. It can see things like a Word document launched PowerShell and start encrypting a bunch of stuff. And then in Defender ATP, we can do things like isolate that machine from the network. It basically instructs the computer to configure the firewall to not allow inbound and outbound traffic unless you're talking to what's essentially the ATP C2 to control your corporate machines. And then you can see, well, who was on the machine, what processes did they run, what files did they touch, who else might be impacted by it, and start taking some remediation actions quickly. So Defender ATP is an enterprise thing. Windows 10 can do Azure AD Join, and BitLocker is on Windows 7 Enterprise and Windows 8 Pro and Enterprise and Windows 10 Pro and Enterprise too. So lots of options to use BitLocker. Just please use it. So Now that we have found our way into the machine, let's do the next step, which is to try and find something that's useful on the computer. So let's jump back over to this workstation, and I'm logged into this computer now as the Haxor account. And we can do basically what we started doing with the notepad off of the CD, right? Browse to the C drive and go to users. And under users now, we can see, hey, here is David's content. We can go in here and say, hey, you don't have access to David's stuff because, well, I don't care. I'm a local admin. I'll just take permission, right? Because I own the whole file system as a local admin. So I get myself permissions to David's content now. I can go into his documents and I can see the same stuff. So let's go ahead and copy all of his documents to my exfiltration drive. And once we go over here, we can go to the USB drive and paste what we've got here in his documents. And that way we can start copying groups of things instead of just the one file at a time with Notepad. But if we go back in here, we can also see that David is actually using OneDrive, and OneDrive for Business in this case, and OneDrive actually does an offline sync of his files that are in OneDrive. So even without being connected to the internet now, I can start browsing through what he has in his OneDrive. So let's go ahead and jump in there. We can see he's got some documents, and one of them that are really fun is this passwords text file, which is not an uncommon thing. And so now I can say, all right, what services does this guy use? What kind of passwords does he use? Can I go in and start messing around with his bank and his cell phone plan or whatever he might have in there? Sometimes we'll see text files like that. Sometimes people are using, a password-protected Excel file, which whoop-de-doo. And then we can take all these passwords and start using them. So for now, we're just going to go ahead and take this stuff. But if you are in that case where people have a lot of passwords that they need to deal with, using a password manager makes a ton of sense, right? Something like KeePass or LastPass or Dashlane or something like that you can use for managing passwords individually if your organization doesn't have something for you. Azure Active Directory does have the ability to do some password management, most useful for things like SaaS applications and web apps. So you can create an application panel. It's basically a dashboard or a springboard where you go to the web page, you log in with your corporate credentials. It shows a list of all the SaaS apps that you have access to, and you can click on them, and it'll either do single sign-on with your Azure AD account, but it can also do form fill. So if there's some web apps that just have a username and password field, you can, as an administrator, add those as a custom application and say, this is the username field, the password field, and the login button. And then when you assign a user that application, you say, here is their username and password that they should use. They click on the tile, and then the browser plugin form fills their username and password and hits submit for them. So they never even need to know what the password is. And then you can still retain ownership of that corporate asset. So let's go ahead and steal his OneDrive stuff. We've got pictures and taxes, so we'll copy that, come over here and paste that. So now we've got his documents. Another one that's really good to do is under App Data, and under Local, under Microsoft, under Outlook. And then in Outlook, we can come in here, copy this Outlook data file and paste it, and now I just took his inbox. So even if it's cached content, right, if he used the cached inbox, I can steal what's inside of his mailbox, and now what can I find inside of this mailbox? Like, everything. Right? That's where we put everything. It turns out that's where we store all of our corporate information on how to access stuff. If this guy was recently hired, we probably got some onboarding information. We probably have some VPN information and credentials. We probably have some Wi-Fi pre-shared key stuff in there. We probably have access to third-party SaaS apps. We can also kind of dig through this and start building a profile of this guy's relationships, who he likes, who he doesn't like, who his partners are, who his enemies are, who his customers are. What's motivating him? See what his favorite TV show is and start using that to kind of build a larger attack later. But if we have all of this information in here, we have to start thinking like, well, what can we do to protect it, right? So let's jump back over here to our deck again. And what can we do to stop some of the stuff that we just did here? I'm basically just stealing files off of the machine. Well, for starters and kind of indirectly, BitLocker helps here too, right? So if I can't get into the machine interactively, I still wouldn't be able to actually just take these files off natively, right? So if I had booted off the CD and I was using Notepad or some other kind of file control tool, I couldn't go in and just take these things off of the disk either. So indirectly, BitLocker helps me here. But if I was trying to do some sort of a remote command and control of this machine with a shell or something through like a macro phishing attack or something, David has access to these files, and running in the context of David, I would be able to access and copy these. But if I took them offline, I could protect them with something like Azure RMS, which is actually called Azure Information Protection now. AIP allows you to encrypt those files on disk, even if it's on top of an encrypted disk. So, right, double encryption, but that's fine. So when we are encrypting these files, if I take a copy of them, the only way for me to actually read those files is if I am actually David. I need David's credentials, and I need access to the AIP service to get the decryption key to read that file. To David, the actions of opening and decrypting those files is really quite transparent, because access to those files is done automatically through in many cases, Office. So if you're doing those encrypted Excel documents or password protected, you can use RMS instead, and that's a much better way of protecting that file. But as an attacker taking a copy of that file, I'm not going to be able to open it because I don't have his credentials to get the key. But beyond just encrypting files, we can also encrypt email messages. So when we're doing that onboarding with the employees, we can say, here's the information I'm getting on our network, and we send it with an RMS protected message. David will be able to open and read it and not have to do any behavioral thing that's different than any other message. It will just automatically decrypt and show him that content, but he won't be able to forward it or print it or take a screenshot of it. So he'll be able to use the information to get online, but he won't be able to distribute it or have it get lost. Another piece that Windows 10 can do is something called Windows Information Protection. It really uses RMS under the covers, but instead of having the application developers need to put the SDK for RMS in their applications to have an enlightened application like Office is, Windows will take care of it for you. So now as a business, we can say this is an enterprise application, and this enterprise application requires you to encrypt the files that it creates. So you can say WordPad, for example, is an enterprise app, and now these rich text files are going to be encrypted with AIP. And again, the Windows takes care of that instead of the application taking care of it, so you no longer need to have third parties be on board with the RMS ecosystem, because Windows will just do it for you. So that's some of the options for protecting those files. Let's jump to the next part where, all right, we've gotten some files off of this machine. How do we get off of this machine and start making our way onto the CorpNet? For this one, I actually have a separate machine here because I wanted to mess around with the wireless network, and wireless networks on a VM is kind of hard, so I just have a different laptop to do this part. But I'm logged into this machine as the same Hacksaw account, a local account on a domain joined machine that David had used before. And what we can do is take a look under the network settings, and we can see all the other wireless networks that are in the environment. We can also click on network settings and see known networks. This is a list of all of the networks that this computer has attached to before and is set up to automatically connect to if it sees it. If in this case, since David did this, the user I'm logged in is the Hacksaw account, so I'd never connected to these before, but David said automatically connect if you see these. That actually instructs the computer to do that, so now the computer has saved the configurations for connecting to this network. And since the computer knows how to connect to it, that means it knows the pre-shared keys to get onto that network. And since I'm local admin and I can do things as a system, I can go ahead and get those passwords. So what we can do is open up a command prompt here. And we'll change over to my desktop. And desktop. And then we can use NetSH, right? This is a real strong hacker tool. We're going to use NetSH to do WLAN, and we're going to export the profile and set the key to clear. Oh, I spelled WLAN wrong. WLAN. There. And what that does is it generates a bunch of XML files, including this one called Nate's iPhone. Nate's my boss. So in this XML file, you can see the SSID of the network, and over here under key material, this is the plain text pre-shared key to get onto his iPhone. If he was here, that would be even better, but you can see now that this wireless network I can use any device to get connected to. And if I wanted to figure out where this network is, I have a couple options. One is I know the company that this laptop came from, so I can just look them up and their website will have a contact information and drive to their office, and I'm probably good. I might look up the SSID on wiggle.net, whatever it might be, to try and find the location of this network, and now I can go ahead and connect to these things with either the laptop I have, or maybe some other devices that I want to bring in, but I don't have to hack it, hijack it, or man in the middle it. I just have the pre-shared key now. So let's take a look real quick at what we can do about this. Well, for starters, this is something that local admins can do. So if you ever get local admin on a machine, like this isn't something you can really block. Local admins have the permissions to do this. So if you're doing things like pre-configuring wireless networks for your employees, not telling them the password because you don't want it to get out there, well, all those employees out there, this is how you get that password. You just netsh, and you can put any device you want on the corporate network now. If you wanted to prevent this kind of access, you basically have to stop using pre-shared keys and use other methods, right? If you can use certificate-based Wi-Fi, that's actually a lot harder for people to get access to, because instead of using the pre-shared key to get on, you have to have a client certificate to authenticate to the access point. There are methods that I've seen, like Mimikatz can actually export the private keys even when they're marked as non-exportable, which is kind of awesome and scary, but if you can get that key, now you can use that in other places. We can also consider using radius authentication, because I would still need my Windows credentials to get on that wireless network. And at this stage, I don't have any domain credentials. I just have that local admin account. So I might get access to the wireless network, but I still can't actually get authenticated unless I do a radius authentication. And because pre-shared keys can be kind of a pain in the butt, most people use really simple passphrases that people can remember that are really short. And there's a lot of ways that we can actually get those pre-shared keys over the air. That's another project I'm working on. But it's actually really easy to steal password hashes for pre-shared keys right out of the air and run them through cracking software to get those pre-shared keys. So use long passphrases on your wireless networks if you have to use PSK. But if you wanted to manage that, because they might be long and annoying to type long passwords, you can use group policies or mobile device management to pre-configure those devices without having to tell people how to type a 32-character password, for example. All right. Oh, yeah, there's more. So now that we've gotten through that point where we have gotten into the network or onto the machine and we found some information, it's time to start doing some more of the recon stage. So let's assume that I've gone to this office and I'm going to connect to their network, and I can start snooping around the network now and do some recon to figure out what's useful out there. So we've compromised the machine, and we're going to jump into a server. So let's jump on this computer again, and this time what we'll do is usually a good place to start is just trying to figure out what's on the network, right? We could scan it and that sort of stuff. But I know my ultimate goal is to get into Active Directory, so I want to know where their domain controllers are. So let's go ahead and open up a command prompt here. Click CMD. And we'll open up a command prompt and we'll run it as elevated, because that's always fun. And one of the tools that I usually use to look at Active Directory is nltest. So nltest/dc list, if you add a colon, what that'll do is it'll query the Active Directory to try and find all of the domain controllers in the environment. Well, in this case, you can see it actually gives me an error that says, hey, you don't have access to do a directory services bind to the domain controller. But lucky me, it still tells me the name of the one it tried to talk to and the name of the primary domain controller. So if I wanted to, I could just kind of stop here and start targeting the DC3. But I know that nltest would usually show me more information than just these 1 or 2 DCs that it tried to talk to. It will tell me things like Active Directory sites and that sort of stuff. But because I don't have an account that's in Active Directory, like I can't talk to Active Directory. But fortunately, I have a domain joined machine, and the domain joined machine can talk to Active Directory. So let's go ahead and use an elevated command prompt. And remember, if we did sticky keys, 1, 2, 3, 4, 5, we get this up. But if I say, who am I, I'm actually not running in the system context now because I'm not at the lock screen. So it invoked it under my persona. So instead, what we can do is use a tool, but this time Windows Defender is going to try and stop me. So we'll go into Defender, and because I'm local admin, I'm going to go say virus and threat protection, real-time protections off. It says, are you sure? Damn right. We'll close that. And then we can go on to my USB drive. And on here, we have a tools directory. So here's a couple of tools that we've got set on this machine, including PSExec. So let's go over to the E drive, we'll go to tools, and we'll run PSExec, but we'll run it with the system, interactive, do not wait, cmd.exe. And then we have to accept the EULA because that's the rules. And then we say, who am I? And we can see again, now I'm back in the system context. So thank you, Mark Rusinovich. I really appreciate that. And we can go ahead and run stuff in system context again. So let's run that same command. Let me actually change this real quick so you can see it a little bit better. Change here and here. We'll do this too. All right. So nl test/dc list. And now this time, instead of giving me an error, I can actually see, look, there's a couple of sites out here and there's additional domain controllers available. So if I wanted to kind of just get an idea of what options I have, that's actually a pretty simple way to do it. But now that I can do queries against Active Directory, I might want to do things like tell me what your users are, tell me what your groups are, right? So again, we can use net user in the domain. What'd I do? I typoed it? Net user, net user in the domain. All right, so now it dumps a list of all of the users that are in Active Directory, and that can be pretty useful. We can also say net group. I typoed that too. Group in the domain. This will tell me all of the groups that lived in the domain, so we can start profiling the network and say, well, groups usually indicate function, right? So we can see roles that people have. We can see servers, services, and that sort of stuff. But we can also be more specific, and we can say net group domain admin. And now we can see domain admins, plural. And now we can see all the users that are actually domain administrators. So now we've really narrowed down our list of the targets that we want to consider because we know the domain controller, where it lives, and who have privileged accounts. Well, in this case, we can infer a little bit more, right? We have this dummy account, we've got help desk, we've got Mike, we've got a couple others with these A dashes, including this Shannon chick. And with it, my name's Shannon, by the way. So when we look at the list here, we can kind of infer that these A dashes probably mean people, right? They're administrative users. And there's S's there, and those S's are probably what? Services, right? What do we know about service accounts and their passwords? They never change. So if I wanted to go after something, a service account that's a domain admin seems like a pretty solid deal. And we can infer some other stuff like, hey, they've got a SQL account that's a service domain admin, a SharePoint, and so on. There's even this one over here called app service. So if I wanted to try and find a server that is using this service, I might want to just look around at computers and see if there's some sort of name correlation because humans like that sort of stuff. So what we can do is try and get a list of computers. Well, if we try and do NSLOOKUP, NSLOOKUP will let me do DNS queries, and one of the options that we have with NSLOOKUP is this ls option. And ls should actually give me a dump of all the records that are in the domain. So if we do ls for techready.net, which is the domain here, and we can write that out to file.txt, it would try and do a query against the domain controllers. Well, I'm not using an older version of Active Directory, so it actually refuses this query because I'm not a registered name server in the domain. So it says you can't do a zone transfer, silly. You can't have those records. But I have other options that I can do some queries with. So let's go ahead and exit out of this. Go back to our friend comp mgmt.msc. And in the computer management console, I can go back to our users and groups, and under groups this time, just pick a random one like admins because it's funny. Go into add, we'll go to an advanced search. We'll change the object type to actually just be computers. And then we'll go ahead and hit find now. And then this will basically dump all the computers that are in the directory. right? So I can see in here not only the domain machines, but I can see where they live in their OUs. So I can start making some other inferences saying like, well, here is a SQL server, assuming by its name. We have some domain controllers, directory sync and DHCP, but there's also this server right here called app server, and I have a service account called app service. So if I was a betting man, I'd say they're probably related to each other. So I want to go after app server. And it's because I'm going to try and find the app service account. But if I was the IT guy in this company and I needed to administer this server, how would I access and control that server? Remote desktop, yeah. RDP is how I would get on this as an admin. So if I wanted to RDP to this machine, I need credentials, right? Well, I don't have a domain credential, but I do have that local admin account. So if I look back on my workstation and start digging into that local admin account, maybe I can get lucky. Let's see what happens. Ooh, the mystery deepens. Okay, so I'm running here as the system context of this machine, and I want to get access to the to basically the local security authority, the LSAS data, the SAM database. So if I go back to my tools directory, tools. I have another tool here called CQ Secrets Dumper. If you've heard of Secure Academy, CQ Secrets Dumper is a tool that they wrote that allows you to see the secrets that are in the registry. And since the local account database is on this machine, that means all the credentials are on that machine. So we can use Paula's tool here called CQ Secrets Dumper, and she shows how it all works in this blog post here. So you can go ahead and read it, download the tool. But we can actually go ahead and dump that out. So if we do CQ Secrets Dumper and just run that. Oh, actually, you know what? I'm skipping ahead of myself. That's not this one. I need to use Mimikatz. Different tool. You've heard of Mimikatz, yeah? Yeah, so use Mimikatz. So we're going to do more on Mimikatz. This command here is just going to launch Mimikatz, and it's going to run it in debug mode, go to the LSA authority, and it's going to dump the SAM database. So let's go ahead and run this. And then Mimikatz runs, and it can show me these, which are the hashes of the local accounts on the machine. So now I have a hash of the local admin account. If I wanted to get the plain text password of it, I could take this hash and I could run it through, Hashcat or John the Ripper or something like that and try and crack it. But I want to be really lazy. So what we'll do instead is we'll copy this. We'll go use this other hacker tool called the internet. Instead, we're going to go to a website here called crackstation.net. And CrackStation's got this nice little text box that we can type this into and then prove that I'm a human by trying to spell and talk at the same time, which maybe proves I'm not human, I don't know. And then it will look that hash up in its database, and voila, I've got a nice plain text password, and I don't even have to crack it. So, takeaway from this is use good passwords on your privileged accounts, because if I can just look it up, like that's bad. Password managers and so on, using generators to create these passwords that you don't generally use and invoke, right? You should have really strong, long passwords. But now, fortunate for me, I actually have this plain text password now to get into this machine. All right, so let's go ahead and go to the slides real quick, and let's ask the question, what could we do to stop that? I went through quite a bit in that segment there, but the password part, we can use laps, right? If I don't use the local admin account and just leave the administrator account be it, I can have laps manage that password for me. I generally am not going to use the administrator account because in newer versions of Windows it's actually disabled, so we're not going to be using it unless we're rebooting into like safe mode or something. But that password can be managed and not be replayed on other machines because laps can take care of it for us. If we wanted to prevent the use of some of the tools like Mimikatz, you could use things like Device Guard and maybe App Locker. App Locker doesn't prevent local admins from doing things because App Locker is provided by group policy and local admins can circumvent group policy, but Device Guard not so much. We can also use things like Credential Guard, which would protect that security database from dumping, at least from memory. And for monitoring, we can use something like Microsoft's Advanced Threat Analytics. So all the actions that I was doing for querying against the domain to find those list of users, to do the name service directory dumping, those things are all talking to the domain controllers. And ATA has network mirroring on the DCs. So any communications with the DCs, ATA can see and analyze and tell us if something nefarious is happening. So we can see things like massive account deletions. We can see irregular logins. We can see doing DNS enumeration and getting access to that information. So at the time of occurrence, we can start doing remediation actions, right? We can say, hey, somebody just tried to dump the list of the users. Let's figure out what happened there, right? We can see the computer it came from, the account that was used, and so on. So that's one option we can go through for monitoring. All right, so we've got credentials. We've got a local admin account. We've got the plain text passwords. Let's do some lateral movement, like an IT pro, which means using remote desktop. So go ahead and copy this password because it's super complex and I don't want to typo it. And we'll go ahead and hit remote desktop. Now the server was app server, right? We found that in our list, so we want to go to app server. And once we connect to app server, we want to log in app server as our local admin account and paste in that super password. And I'm able to log in. So good. Now I'm actually getting access to this app server, and I'm presumably a local admin on this machine. So that was, a lot of work. Let's go back to the deck. What can we do to stop that? Well, in this case, Laps helps again, right? Because if we did have a local admin account like that, we could use Laps to manage that local admin account, and I wouldn't have the same password on both machines, so I wouldn't be able to use that credential to jump into it. We can also make some rules in the Windows firewall, just the host-based firewall, that says who's allowed to actually do remote desktop, right? We can do that in a number of ways, including users, and we can say IP subnets. We can say you can only get in from a jump box and that sort of stuff. But using group policy, we can say this server will only allow remote access for certain sources. And if you think about it, what I just did was jump through the server from a laptop on Wi-Fi in somebody's parking lot. Right, so network segmentation also comes into play. We want to make sure that you can prevent access from places they shouldn't be coming in. All right, and we can also use a group policy that says local accounts can't be used remotely, right? So I used local admin, it only lives on that machine. You can make a policy that says local accounts can't be used to RDP in. All right, so now let's level up here. We are still using a local admin account, but we want to do something more with a domain account. We can profile this machine and try and find things like, is there a SQL database on here? Is there some other records or applications that we want? Just looking at remove programs or whatever. But we can also go into the services MMC, and under the services MMC, we can tell here, look, we have the app service account running the service on this machine. Well, when this computer reboots, it has to launch the service using that account's credentials. And since that happens essentially offline, this computer has the credentials stored. And again, I can become system, so I can get the passwords for this account. So let's do what I tried to do earlier and actually use the CQ secrets dumper. So we're going to need the secrets dumper, and we'll need PS exec. So we'll copy this, go over to our server, we'll go to the C drive, and we'll make ourselves a tools directory. And paste our tools in there. We'll open up a command prompt, and we'll go over to the tools directory. All right, and we'll do ps exec system interactive do not wait for cmd.exe. And then we'll go back to our tools directory, and we're going to run the CQ secrets dumper. And this is a useful tool. It gives us a help and tells us how to use it. It basically just says you need to use a CQ secrets dumper, specify the service name equals, service equals. And if we look over here on our console and double click on this, the service name right here, we can just copy that, go over to our command prompt and paste it. And then this dumps this little block out here. So we'll go ahead and copy this, and then open up another hacker tool called Notepad, which we used earlier. We'll paste that, and we'll go to edit, replace. We'll take all the dots away, replace it with nothing, and then we can go ahead and remove these line breaks. And this is our plain text password for that service account. And it's a good password, right? It's long, it's complex. Like trying to roll this through a cracker if I use the hash would be really hard, but it's just stored in the machine and local admins can see it. So service accounts are kind of a risky way to go ahead and get that text. But let's jump over here quick and see what can we do to stop that. Well, instead of using an account in Active Directory, we can use what are actually service accounts in Active Directory. Service accounts can be managed by a computer just like a computer account, and you can say this computer can use this service account, and then that password doesn't get stored anywhere because it's delegated the permissions to invoke the use of the account. Now, of course, if you have local admin access to that computer and you can run a process and you can use the account anyway, your service account should still just not be a domain admin. Like that's kind of like the first rule. Don't make local or don't make service accounts domain admin. But using group managed service accounts, we can at least prevent access to the plain text passwords. Preventing the use of the tools with things like device guard are a good way to go, and preventing access to these machines using service accounts we can do with group policy. And for monitoring, if you use another system internals tool, we've kind of been beating up on Mark for his PS exec, but sysmon is another tool that they wrote that allows you to generate a whole new set of events. And if you harvest those events, you can see things like process starts and stops and forks and network connections and all sorts of interesting stuff. And Swift on Security has a example kind of configuration that will get you started on using that. I actually took it and made an MSI that installs it so I can use group policy to distribute sysmon through group policy. And then everything on the domain gets it, and you just have to harvest the events. So it's a really useful tool. It installs as a driver instead of like an agent. So, all right, last stage. We've gone through, we've found our way to the server, we've got a domain admin account. Let's go ahead and jump to the Active Directory and steal some credentials. All right, copy this password here, and we know the domain controller we're going to go after is the primary domain controller, which we saw earlier was DC3. So let's go to DC3, and this time instead of logging in locally, we are going to log into the domain, and this time it's the service account called app service, and the password. We'll log in, and yay! I have access to a DC. Woo-hoo. That was 3 hops and we're in. Okay, so now what we want to do on this DC is get Active Directory, right? So let's go back to our tools, and I've got this quick little batch script. Notice how I'm doing everything in batch. It's not even PowerShell. This stuff's like ancient and easy. So let's go back over here to our DC, open up Notepad, and paste this in here. What we're going to do is make a directory and then use volume shadow copy, because volume shadow copy lets us copy files that are locked. On this domain controller, if we go into Explorer, we can see we have a C drive and an F drive, and the F drive is actually where we have the Windows ntds.dit file, and this is the actual database. But since it's a running and functioning domain controller, the file is locked, and we can't just copy it because corruption might happen. So what we can do is use this volume shadow copy to create access to this file for us. So we'll go ahead and paste this command in here, make the directory, create a shadow, and you can see right here that it creates this hard disk volume shadow 3. So we'll go back to our little script here. We'll say we want shadow 3. We're going to do it again on the C drive, and we know incrementally it's going to do 4. But there's actually this the system file and the ntds.dit are the 2 things I need to get access to this. Let's go ahead and paste that. And now we can see on our C drive under Pwn, we now have the 2 files that we want. Copy those, go back to my USB drive, and paste that onto my USB drive, and I will have successfully stolen Active Directory. Huzzah! So let's jump over and do the same question. What can we do to stop this stuff? I'm going to take a beer break. What can we do to stop that? Well, we need to stop access to the domain controllers, network segmentation, right? If you can't touch the DC, you can't get the database. We can use group policies to say if you're not a domain admin, you can't get into a DC. We can say if you are a domain admin, you can't go on to other things, which basically stops the credentials from getting passed around. And then further isolation of the DC is like you mentioned earlier. If I get physical access to the DC, I could use that whole boot from media and the notepad trick to steal those 2 files, right? So if you have a DC under a desk somewhere, you probably want to make sure you don't do that. All right, so here we go. We went through and we attacked and stole all the things, mitigation stuffs that we talked about on the client side. We did some sticky keys hijacks. We didn't talk about macros, but if you want, I have some other stuff to show how that would work too. And stealing data off of it and pre-shared keys. Stuff to prevent that, right? We can use BitLocker. Good tip to take away is encrypt your stuff. You know, you can dance like nobody's watching, but encrypt because everyone is. Use some macro securities if you're going to prevent the remote shells. If we also do Intune for BitLocker encrypting the Azure AD join machines, and preventing local admin for stealing the certificates. On the server side of things is where we did all of our recon, and we were stealing secrets for the service accounts and leveraging remote desktop. We can control that stuff with group policy, use ATA for doing some of the monitoring, as well as Sysmon, device guard, and other group policies to protect us there. And then on the domain side, we only did the stealing of Active Directory, but there's other really cool examples out there that if you have access to the DCs, like skeleton key is really fun. But if you go through protection on that, we're basically looking at isolation and group policies for hardening access to the machine. So that's kind of the quick overview of everything that we went through. When I end up talking with customers about doing security improvements in their environment, we usually end up talking about NIST CSF because it's crosses industries. And I kind of put this together as a way of saying, these are a list of some of the Microsoft products and services that you can use to address those different categories inside of CSF. So if you're looking for something specific that you think you need to improve, these products are a way that you might look into configuring. We also do talk to customers about how they're currently standing and rate you with scores and help you kind of build some momentum on improving security. But I'd be remiss if I didn't say thank you to you guys and to some of the examples I have on the screen here. I've learned a lot in the last 2 years, and I really appreciate the community sharing out there and the opportunity to come out and kind of summarize what I've learned so far. So thank you very much for having me, and I hope you found this useful. All right. And I'm around if you guys want to ask me somewhere. If you have some stories to tell me, I love hearing stories, so feel free to come on up.